Hey everyone, in this video we're going to take a quick look at how to make an endless runner, and we're going to have it occurring along a round surface. So I already have a tutorial about making endless runners, so this will probably be just a one-off unless you guys want to see more. But the reason why this merits its own video is because the way the world is created and the way the character moves are entirely different. So even though it's the same type of game, it's an entirely different approach, so I figured that was worth calling out. So as a quick recap, in the previous game, it was meant to be like Subway Surfer. So as the game progresses, more and more track, more and more ground is placed along the z-axis. So it's placed at Z0, Z3, Z6, Z9, Z12, so on and so forth. Track is being laid along the z-axis, and the camera and player travel also along the z-axis. So as the game is progressing, more and more track is being created along the z-axis, and the camera and player are moving along the z-axis. When you're running along the surface of an orb, it's an entirely different approach. In fact, it's a lot like a hamster wheel. So if you think of a hamster wheel, rather than running along the inside of the wheel, imagine if the hamster is on top of the wheel, okay? The hamster really isn't moving. It's keeping the same place. And the wheel itself isn't moving position, it's rotating, it has angular velocity, but it's not moving its position. And yet, from the hamster's position, it looks like it's running along a surface. So that's really what we're emulating, is that kind of dynamic of a hamster running along the top of a hamster ball or a hamster cage, that the wheel is not moving its position, it's rotating, but it's not moving its location. And the hamster is also not moving its location. The player can move side to side, of course, to dodge out of the way of obstacles, but overall, its position isn't otherwise moving. It's not traveling further and further into the distance. Okay. So first, what we need to do, we need to create that. I'm going to say orb, but it's really using a cylinder. So we're just going to drag and drop this into the scene. Now, for whatever reason, when you take a model and you drop it into Unity, it creates this extra transform object, and I don't understand why, because this has a transform, but for some reason it does that. Don't understand why. So what we have to do, I was going to try to separate it. You actually have to right-click and choose Unpack Prefab. Now you can separate this out and delete that, and we'll rename this trench. And then now it's just rinse and repeat. Take trench L, put it in, unpack, separate it, delete that top level one, and rename it. Again, I'm not sure, well, I shouldn't say that. I have no idea why Unity does that. I can't see why you would want that extra prefab, except in the extra top level object, except in some very, very unusual use cases. So trench M, and then trench. Sorry, I keep trying to drag and drop it. Got to choose unpack. Now we can. And that will be trench right. Okay. So what we're going to do now, these models are already in a model folder, so we don't have to do anything else with that. And we're not going to mess with them for the rest of the video. So we're going to select all these. And we're going to add a component. We're going to add physics, and it's going to be a rigid body. Okay. Get rid of gravity, or else the whole orb is going to fall, and get rid of angular drag because we don't want it to slow down as the game is progressing. Already has a mesh renderer, so what we need to add are mesh colliders. So again, physics and mesh collider. And that will let us detect collisions. Now, the last thing that we need on this we need a script which is going to control rotation. I don't want to jump ahead and do that yet, so we'll create the script, but we won't go into the actual scripting until we make our prefabs. So right-click, create C#, and we'll call this world run, world rotate, whatever you want. We'll click on our objects, we'll drag and drop the script, and now these are ready to be turned into prefabs. If we had skipped any of these steps, we'd have had to gone back and change like each and every one of them. So this is the bulk of what we're going to need to do. So actually we have to do this one at a time. So now we have prefabs and we can delete these all from the scene. Okay, so let's start with our one that has no trench. And what we're going to do, we're going to rotate this towards the camera. So let's do a rotation of 90. And let's also do 90 on Z. And now we just have to position it so it's in line with the camera. And just kind of eyeballing as far as whether or not it's centered. In your game, you'd want to make sure it's centered. And the reason I put some ornaments along the side here was because I wanted to be more obvious that animations were occurring, but then I thought about it. In your project, you'll have textures, you'll have obstacles, so it's going to be very obvious that it's rotating. I was just trying to give a few more indicators. So let's click on main camera. So it's not lined up quite right. So if we click on our object, push it away a little bit, go back to main camera. That's pretty good. So you could keep it like that deep in the trench, or if you want to, again, want to be able to see the edge here, then you could do that. And now you can clearly see the curved horizon. So what we're going to do, we're going to take this, we're going to copy it, we're going to paste it, and now we're going to just change the Z rotation. Let's change that to 0. Copy, paste, -90. Copy, paste, 180. Now I'm going to keep emphasizing this. We haven't changed the position. We've only changed the rotation, and now we've gone from a quarter of a sphere, again, it's really a cylinder, to a full one. So I'm hoping that that gives you a preview as to how this is going to work, that even without changing position, by rotating, it fills in the gaps. Okay. Okay, we need to make one quick tweak to something we did a few seconds ago. We need to select the objects that are in the scene, and Mesh Collider, set this to convex and set this to trigger. Why? Well, when I was testing, Unity was thrown an error and it said that it did not like the combination of a mesh collider and a rigid body that isn't kinematic. Couldn't tell you why. However, having this be a trigger and being convex shouldn't have any meaningful impact on what we're going to do. So go ahead and just select the objects in the scene, well, these 4. Set Mesh Collider to convex and trigger, and then do it for the 4 prefabs as well. Okay, so now we want this to rotate. So that's easy. That's actually just one command. So if we go to our script, in the start section, because we want this to happen as soon as the object is instantiated, get component rigid body, and we said we added a rigid body just a few moments ago. And here's the angular velocity that I kept mentioning, and it's vector 3, because you can add velocity to the x, y, or z axis. We're going to do x, and we're going to do -1, so it's approaching it's rolling towards the screen. -1 might actually be a little bit fast, but you can always decide for yourself what speed you want to use. So we save that. We run this. And there you go. So in approximately 10 minutes, you have now created the basis of an endless runner that is on a curved surface. So whether you try to make it look like an orb or a sphere, whatever, you now have this endless sphere. Now, obviously, it's the same environment over and over again, so this doesn't seem that impressive. What is impressive, though, is what we're going to do next. What we're going to do is based on these quarter positions, we're going to swap it out with a different one. So right now it's the same force spinning over and over again, really not that impressive. But as I said, we created these that have these pits, and you can make even more. You take your template, whatever 3D modeler you're using, and you can put pits, you can put crates, you can put trees, whatever you want. Okay, it's just rinse and repeat at that point. So what we want to do is we want to swap out one of these for one of these. So how do we do that? Well, you really don't want to swap out this one here because you might see a little bit of pop-in. So if you're trying to avoid pop-in, then really this one or this one is the one that you want to use. We'll use this one. There's lots of ways to do this. You could try to base it on its angle. I like to use collisions whenever possible because they're so easy to control. So we're just going to go to Game Object, and we're going to create empty, and we're going to name this change obj, so it's change object, change collider, whatever you want to call it. It's going to basically be an empty object, except it's going to have physics, it's going to have box collider, and let's give this like a size of like 12, 2, and like 5. And then we just want it to be right and you want to make sure it's definitely overlapping this position, this object. That way, when the object curves into it, a collision will be detected, and then something will happen based on that collision. So what will that be? Well, let's go back to our script. And actually, I forgot to cut this out from when I was testing, but you can add this private void on trigger enter. And if you're using Visual Studio, you only have to do on trigger enter, and it does the rest for you. Okay, so other. This is referring to just that, the other object in the collision. Well, this is attached to the quarter wheel. It is not attached to the collider object. So that means the other is referring to this. So what we say is if that other dot name, I think we can just do dot name. We might have to do game object dot name. Let's see. If other dot name is equal to, you have to do a double equal to, and let's see. Let's just actually highlight that and copy it so I don't get the spelling wrong. Nothing worse than code not working just because you made a typo. Happens all the time to me. So if the other name is change object, then we want something to happen. What we want to happen is the current object to be deleted and a new object to replace it. So how do we do that? Well, we kind of have to pause here. So what we're going to do, we'll pause with this. We'll put a pin in this, and we need to add something. We need to make these objects aware of each other. So public transform capital T. Some people have said that this doesn't work, and it's because they use a lowercase t. And we'll do no pit for the one that has no pits. Whoops, sorry, that is supposed to be a semicolon. Public transform L pit because it's the left. Public transform M pit because it's the middle. Public transform and R pit because it is the right. So now, you click on any one of these, you'll see now has those references. So what we're going to do is just one at a time, we're going to click on these and drag and drop the 4 prefabs. And because of the repetitious nature of this, I'm probably going to drag and drop something wrong. I apologize in advance, but it's just rinse and repeat. Just no pit to no pit, left to left, middle to middle, R to R. And again, you have to do this for each one. We'll make sure that it worked for the ones in the scene as well. All right. And so we'll come up here. And sure enough, they do. Okay. So what we want, when the collision occurs, we want them to randomly choose one of these. Well, instead of doing the random right away, let's just put one of these in just to make sure that the collision is working and the swapping is working, and then the randomization will be the second step. So what we want to do is instantiate. So when an object hits the collider, we want a new object to be instantiated. So let's just do, right now all 4 are the no pit, so let's just do middle to make it obvious. Well, they're all obvious. So we want the M pit object to be instantiated. Now this is very, very important what you choose. Okay, the position isn't changing for any of them. So let's do transform.position to make sure it's using the position that is currently utilized by the object that's being deleted, and then about to be deleted. And then we want to use transform.rotation. So use the current rotation of the object that is being deleted, or should I say the object that the script is attached to. And then we do destroy game object. All right, so 2 things happening. When the object this script is attached to collides with the change object, a new object will be instantiated in its position with its rotation, and then it itself will be destroyed, leaving the one that just got instantiated. And if I haven't done anything wrong, that should be all it takes to make this work. Now we would want to randomize so we're not always using that, but that's just a couple more lines of code. There's the middle pit. And there you go. So in maybe 20 minutes tops. Now, true, that's a little artificial because it does take time to make the environment. But as far as a coding point of view, you've now made an endless runner on a round surface. So you need some randomization here. So we could do private, and we can do private int, and it would be which, oh, why am I doing all caps? I'm yelling at someone. Which, actually this is going to be a number, so we'll just call it which one. And then in here, what we do which one, so that new variable we just created is equal to random.range. Now, this is inclusive of the first number, but does not include the last number. So if you want 4 numbers, you have to do 5. I've been told that's only true when this is an int. If it's a float, supposedly it's inclusive to this as well. But doesn't really apply to us because we're using ints rather than floats. Okay, so now what we have to do, we have to now choose which one gets instantiated. So you can do if statements, you could do select switch. So that would be switch, and then the variable that we're using, which is the which one variable, and then curly brackets. And then case 1 colon and then break. There we go. All right. So now let's just rinse and repeat these. So the verbiage or syntax, however you want to say it, it's switch and then in parentheses the variable that you're using, the word case and then the value you're checking, a colon and then what you want to happen. And then break means stop checking. So that's the main difference between a switch and an if statement. An if statement will keep cascading through and through and through. A case statement says, okay, once you hit the right value, stop. Technically, I think if statements would do that as well if you're doing if and else if. So if they're dependent upon each other, effectively it's the same thing. I'm not too concerned about performance. I don't do like high-end games for my tutorials, so I'm not really worried about performance, but it is something to keep in mind. Okay, so we basically have to cycle through these 4. So no pit, looks like a lowercase. Just make sure this is the same spelling. So no pit, transform position, transform rotation, and we'll just cycle through all these. The order doesn't matter as long as you've got a value for each one. And then case 3 will be, so we've got no, left, middle, case 4, all right, that should be all of them. So when a collision occurs, a random number is generated. We check to see the value of that number. If it's 1, we instantiate that. If it's 2, that. If it's 3, that. It's 4, that. And then we destroy the current game object. So there's the center. There's the left, left, center, and there's the right. So that's about does it for this tutorial. You now have an endless runner environment that cycles randomly through different traps. So to keep things simple, what you can do, again, you use the same template, you just put different obstacles, like maybe you put a tree on one of them, maybe you put a crate, whatever, okay? And you just keep adding which one do you want to get instantiated. So that's about it for this tutorial. I hope that you found this helpful. Again, like I said, I really didn't want to do another full tutorial because I've already explained the concepts and the ideas. It's just that when you're on this kind of surface, rather than linear surface, it's very, very different, and in some ways, a whole lot easier. So I think that should about do it. If you have any questions, put it in the comments. If you have any requests, put that in the comments. And please let me know if you liked the video, and please enjoy the rest of your day.